today in this talk, I'll be sharing you some research topic, some area of research on artificial intelligence for future generation robotics. Okay, so before starting these AI part or robotics part, let us see the definition of robotics. There are various people; those have defined these robotics in different way, like like uh, some of uh, some of the researcher in Robot Institute of America, they have defined the robot like programmable, functionable, and movable material parts, tools, or specific devices through variable programmed motion for the performance of varieties of tasks. And Russell and Norvig, they have defined the robot like an active artificial agent whose environment is in the physical world. So there are various definitions of robots, and but the thing is that these definitions of robots are changing day by day. Okay, because because of the transformations of robot from mechanical to intelligent one. If we see the history of robot, robots these robots are basically have started with the idea.
Professor Ghosh, you are muted now. Could you please unmute yourself?
Yeah. Okay. Am I audible now?
Yes, you are audible.
Okay. Okay. Thanks.
And I would like to request the host of this session to take care of this mute and unmute things. Okay, Professor Ghosh, you can continue.
Okay.
Sorry
Thanks.
for the correction.
Thanks. So this transformation of robot from mechanical to intelligent one has a huge journey. It has all started with, we know, the name robot came from a Czech word robota, that means slave, human slave. So basically, at that time in the 17th century, there was people are used as a human as used as human labor. So researchers or the scientists, they are searching how to make a mechanical slave, uh, a machine that can perform as human, so that we cannot use human as a labor. So that's how the robota terms came. That's how these robot came. And uh, and if you see the history, these robots, the first robot was made by some watchman. Three watchmakers were there from the Paris. They have made a human-like structure, mechanical structure, and they use these energy of spring, like just like watch energy of spring can be converted um, into the into the energy, so that the hand can be moved, or the arm can be moved using the spring. So that was the conception behind these robots. So this way these mechanical robot has started. Okay. And then they have thought that people have thought that for human labor we are basically using human hand, right? Arm are basically used. So why not we can use these part of robot specifically for use in the industry. So that's why this type of robot, you know manipulator type of robot, pick and place type of robot has come. And and though it is not not replication of human being, but it is a replication of human arm or human hand, right? So basically whenever we talked about the robot, so we in our mind it has come that a human like structure should be there, but it is always not true, and most of the robot cases it is not at all true, right? So that type of robot, we named as humanoid robot, but basically whatever robot we are using is basically either articulated arm type robot that is mostly used in the industry. And nowadays the definition of that robot also changed. We'll show you in the next few slides here how the definition has changed and what type of modern or advanced robots we are using, right? So the mechanical robot has changed, has started with these robots started with mechanical thing, and the applications were manipulator. uh, but that has changed in 1990s, like after invention of computer, people have tried to incorporate the computer into the robot, so that because robot is doing mechanical work, so it should have some accuracy. So if we include computer into the robot, so it would be more accurate, because we know computer is a machines can do repeated work in the same rate of accuracy, right? So we are also trying to get same type of work, accurate work from the robot. So that's why what they have done, they have incorporated computer into the robot. So the mechanical robot transformed into computerized robot. So these computerized robot, one of the examples of these computerized robot, you can see the some of the humanoid robot like um, Honda Oshimo. uh, so it is a rolling robot. It can walk. It can run. Even it can play football. So this type of robots are computerized robot. Even in industry also nowadays, most of the robots we are using are computerized robot. We need to program it through computer, and as per the program it is running. So that was up to 2000, 2010, or 2015. But very recently, these idea have also changed. Why change? Because the way of working of people, human also change. Nowadays, we are you know most of us are working on the from our home, right? You have seen during the COVID period, we have to work from home, right? So we are using our intelligence, our brain only, not much using physical work like that. So therefore people also, researchers also trying to transform these robots as intelligent machine. Okay, so that is the reason these transformations of robot from mechanical one, only mechanical, without any intelligence, without any brain, uh, has transformed into computerized one to get more accurate work, to get more efficient robot, and then they have changed the robot from computerized to intelligent one, and the example is chatbot. So nowadays, in some reception, in bank reception, or in railway reception, ticket counter, you can see some of the computerized robot. It's basically a chatbot. It's basically a chatbot which you can talk to them. You can ask any queries to them. They will answer you. Right. So the transformation of robot from mechanical to computerized to intelligent, and similarly, the applications areas have also changed from manipulator, like pick and place robot, to rolling robot, to chatbot. So this is the short history of robotics, and this is why these term artificial intelligence and machine learning come into the picture of robotics field. So this is that's why that I have just explained how these artificial intelligence or machine learning come into the picture of um, robotics. So so here we'll see how AI can be incorporated into the robots. Just like because whenever we are making something, we are getting ideas or motivation from the nature. Uh, Whatever things you can see, whatever things, whatever robots we have developed, everything has been inspired from nature. So nature is the best teacher of us. So therefore, in case of intelligent robot also, we are getting the knowledge from the nature, like how human get intelligent, right? How human get intelligent? We know we are an intelligent animal. So how we became intelligent? So as a mm, child, if you see, uh, uh, since the childhood, we are becoming intelligent more and more day by day. How we are becoming intelligent? There are two way to become an intelligent person. What are the two way? Firstly, means basic as for the natural way of intelligence is to get the experience. Whenever we put our finger into the fire at our childhood, and we have seen it hurts us. So that's why we learn that we do not put our finger or anything to the fire, because fire will hurt us, right? So that is called experiential learning. So that is the natural learning. And we all there are also another type of learning, that is that we directly get from the book. Means that is experience of someone has some experience. He or she has some experiential learning, so that he or she has been write down in a book, and that book we are getting. So that is from book also we can get the knowledge, as well as from the experience also we can get the knowledge. So similarly, in robotics also, we can directly program the robot. You have to do these and these things, you have to perform these and these things, or we can mm, fit it into a environment where it is getting some experience, and whatever the experience it is getting, it can be it can incorporate into its program, it can change its program, and accordingly it will react. So that is basically the working principle of these artificial intelligence or machine learning robot. So therefore, in this type of experiential learning robot, it has two parts. First was its training part, means you have to train the robot, and after the training, it you have to apply those training into its program. That is the output. Okay, so this is all about the working principle of these AI and machine learning. Now coming to the future of robotics, if you see, now these robots, as we have started with humanoid robot, and or pick and place robot or manipulator, it is not bound to these particularly pick and place or a manipulator or humanoid robot. Now the field of robotics has uh, you know mm, has all the way of different applications, like it is used in drone. The robots has been used for surveillance, for assistive living robots, for Google car, for medical robotics. You have seen for surgery, for medical field, healthcare field also. A lot of robots are used nowadays, and for future home also we can use robots, and the future of robotics that we have just said is the intelligent robot, human interaction, and as well as facial expression. So these are the some of the applications of robot, and we can say these are the area of future robotics. Now I'm going to show you the in this lecture what I'll deliver today. Basically, I'll show you the scope of research work on AI robotics, artificial intelligence robotics, means, in the field of robotics. Hmm. So we have published two books on this particular field, AI on future generation robotics, which has been published from Elsevier, and another book, Machine Learning for Robotics Applications, that has been published from Springer. So here we have shown different applications of robotics using AI and machine learning. Okay, so here I'll show you some ideas where you can apply these your robotics idea into AI field, and you can start some of the research work. You can think of some of the research work in this field. So what are the field that we have chosen here is like first we have chosen self-driving or autonomous vehicle. So in the self-driving or autonomous vehicle or robotic car, a lot of research works uh, have started. Uh, okay, any questions? I think mm, one of you, Sahajiyar Karim has raised hand. Any questions or queries we can take after the at the end of the session? What you can say? Is it all right?
Yes, yes,
Yes,
Karan.
sir. It's
Okay, 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 okay. You can write down in the chat box. So I'll take at the end of the session. So roughly how much time I have? Nasifa, are you there?
Professor Ghosh, I think you can continue, but I think 1 hour or something like
yes.
that.
Okay, okay, fine, fine, fine. So I'll show you in the areas where you can use your research work, your research skill in the field of AI and ML of robotics. So what are those self-driving cars or autonomous vehicles? We have done some of the works, research work on this area. There are another field, flying object or UAV. There also you can do some research work in the healthcare service, in the hospital assistance. There also we have done some research work, and you can always do some research on it. Service robot is also a good area of research. Then industry 4.0 and robotics, automation, IIoT, IoRT, smart manufacturing. So there also you can do some research. Then surveillance robot in cyber intelligence, improving crop productivity. There also we can do some research. So and finally humanoid robot. So other than humanoid robot, all these areas we have done some theoretical work, mostly theoretical work, research work we have done and published some papers. So that I'll share my experience on that on these topics. And for the humanoid robot, we have developed one humanoid robot. We have named it Maria in our university lab. So that I'll discuss at the end. Okay. So, starting with the first topic, self-driving car or autonomous vehicle or robotics car. Okay. So here, in these particular topics, self-driving car also there are several subtopics where you can work. You can work with self-driving prototype only. There you can use several machine learning techniques, supervised or reinforcement learning technique. You can also work on particularly perception and scene generation. Now, what is perception and scene generation? That I will discuss in the next slide. You can also work on particularly object detection and recognition. That you probably understand what is object detection and recognition. Object detection and recognition, it is particularly required for any robotic car. Means you have to detect the object key, whether in front of you some people are there in the road, or some cars are there in the road, or some obstacles are there, that you have to detect and as well as recognize what is this object. So it is pretty much required for these autonomous vehicle or robotic car. Okay. So this is a particular area. In this particular area also you can work. Means if you trying to work on the self-driving or autonomous vehicle research project, so you can you have to choose any of these particular subtopic, because self-driving car or autonomous vehicle is a huge topic. A lot of a lot of things, a lot of subsections have to integrate it in a particular device, that is autonomous vehicle. Therefore, if you want to work with these autonomous vehicle project or autonomous vehicle, you have to choose a separate a particular subtopic of it. So these are the subtopic, these are the areas where you can work. You can start some of the research work, you can start thinking of something. Okay. So these are the like self-driving prototype, like perception or scene generation, where you can also work. You can work on object detection. You can work on isolated object. Means you have to isolate the some objects from the video image. Uh, Also, you have to choose the relevant object to make a scene, to create a scene, to generate a scene. So that is also another work. So if you see, if you search on the internet, you'll find for a particular subtopic, like in object detection and recognition, you will find thousands of paper, research paper, thousands of research paper where thousands of scientists or researchers or academicians are working on a particular algorithm or a particular topic. Okay. So these are the some of the area of or scope of research in these self-driving or autonomous vehicle. So here I have explained how these self-driving programs are running. Uh, this is for just for your information. I think you will be interested after knowing this, how these self-driving models work, and this will motivate you to work on these self-driving autonomous vehicle project or autonomous vehicle research. Um, Definitely, I think it will motivate you in these research. So, so what is these model actually? How these self-driving car works? So, as I have said, people are inspiring from the nature. So similarly, in case of driving self-driving vehicle also, we have to think how we people as human we drive a car. As a human, we how we drive a car. The first we see the perception, then we have to generate the scene in our brain, that is called scene generation, then plan accordingly what we have to do, how to uh, how to plan of driving, then explain you these things, these four topic. So perceptions need to we what we can see from our naked eyes, right? So that is signals, whether the signals are there, whether any obstacles are there, whether any road bending is there. So that is called the perception. So the same way, there will be camera will see the perception, it will detect the perception. The next one is scene generation, that we can create in our brain. So whenever we see there is a signal, there are some cars, there are some pedestrian in the field. So all small picture, taking these small pictures, we generate a particular scene. This is the whole scene in our brain. So that is called scene generation. So in driverless car also, you need to generate a particular scene. And then third point is planning. So accordingly, the scene generation, we need to plan. If we see some pedestrian there, so we have to slow down. Means we have to think I need to slow down because some pedestrians are there. They may anytime come into the road. So that is the planning. That plan, we need to think, that thinking process, that actually is done by a programming part here in autonomous vehicle, right? So there are basically several AI, ML algorithm, artificial intelligence or machines generation, are basically goes through some training process. If this is there, if some pedestrian is there, so you should slow down, right? So this type of training should be there AI autonomous vehicle car. And accordingly, the final stage, that is action. So I have to think of key to slow down, and action will be we are slowing down. I need to similarly in autonomous vehicle also, as per the planning, as per the programming, the scene generation fed into the programming, and output is the program sent to the actuators or motors to slow down. So learning algorithm we are used. One is supervised learning, and other is reinforcement. So for these first two steps, like perception and scene generation, as we have said, though we have explaining all these terms, these perception, scene generation, action, planning. However, when we are working, we need to work on particular specific area. If we work on scene generation, people are working on scene generation only. You can get thousands of paper on scene generation only, or perception only. So therefore, those working on scene generation or those working on perception, they are working on perceptions only. That we have some papers on particularly on scene generation. There are separate we can use. Basically, nowadays everyone is using yellow algorithm. So this type of learning algorithm, like supervised learning algorithm, are basically used for the perception and scene generation, actions or perceptions or scene generation steps. Whereas the other two, like um, planning and action can be used with reinforcement learning algorithm. Okay, so here we have explained the reinforcement learning algorithm where these planning and action can be used. It is basically we know basically different software algorithm can be used as well as we can use here deep learning algorithm also used basically for a specific type of training or data set. We can use this type of techniques. Okay, so here also we have shown some examples how these autonomous vehicles works. Like first, you can see it's only started with hazard detection, whether there is an hazard or not, means obstacle detection, collision detection, risk level estimation that we have to do. And for this particular subtopic like obstacle detection, several papers are there. Thousands of researchers are working on obstacle detection techniques only, or collision detection techniques only, or risk level estimation. Means it is also very important to measure the risk level, because mm, you need to as a human driver, when we drive, whether whenever there is a car uh, in front of us and going in a certain speed, we have to and and uh, and just press sudden brakes. Then we need to think what would be our risk level. uh, means what would be my speed. Let us suppose from one car is going in front of us, and it is in the it is going in the we are going at a speed of 60 kilometer per hour. So and distance between my car and the that car is around uh, 3 meters. So we need to think about what would be the risk level. Means is the 60 kilometer per hour speed is at the low risk level or at the high risk level. Because anytime it can the car just ahead of me can press a sudden brake. Then what would be the risk level of, means how I can at which how much time I'll get to press the brake. So that's how we have to calculate the risk level. So that is another important concept. So some people are working on this risk level estimation. Other than this, there are several computer vision related work, CV related work, that is white lane recognition. We need to recognize the white lane, two sides of the car, so that the car runs between these two white lanes. We need to recognize the traffic signal. Also we need to recognize the also in some places there is no white line lanes are there. So there also that is called laneless. So laneless driving is another area of research. There also you can do the some research work on laneless driving. There you have to detect the age of the road, because the road color is different, and the age of the road accordingly we can drive. So that is another part of research. So these are the different part of research, different algorithms on the computer vision we are doing. First, we we need to take some videos of these lane. Then these videos are fed into different AI or machine learning algorithm program. Okay, so there it is trained, and after training we will get some, we will measure the accuracy rate of accuracy level. After training, 70% data set can be fed into that training, and another 30% will match with the results. So we'll get the prediction, we'll get the accuracy. So as per the accuracy level, we can start into the real life scenario. So there, here this work has been done where these white lanes are you can see detect clearly. Most of the white lanes are detect clearly in this. So first we need to edge detection of these white lanes. You can see these edges has been detected quite efficiently, and then it has been fed into the new uh, scenario. Okay. So here we have done some work on signal, detection of signal detection. So here also several algorithms are used. Basically, we have taken these LISA data set. It is a I think German data set from Germany. We have received this data set, LISA data set. From LISA data set, we have worked with CNN algorithm, and we have received around 43.5% accuracy. And these are the different signal like go left, stop like these type of signals that we have worked with. And this is the traffic sign. Different traffic signs you can see is there, like stop, go left, go right. So that also is a area of research where you can do some research work to detect these traffic signs. Okay. Now the result of this traffic signal recognition, that you can see different signals like go left, stop left, warning left. So this number of training data set we have used, like more than 9,000 training data set we have used, and 1,000 more than 1,000 test data set we have used, and we have received more than 90% accuracy for detecting these go signal. However, this go left signal, the accuracy level is little lower than the go signal. Stop signal also quite accurately we have detected, and warning signal also very high rate of accuracy you can see. So 99% if you see 99% rate of accuracy, that means out of 199 times we have detected in right way. Now coming to the laneless driving, this is also another work that we have done, laneless driving. So first, what we have done, some of the there are two types of roads are available in laneless, like there is no white lane. So what are those two types of lane? One is paved road, means there is a paved, two sides of the road there is some paved. So that is one type of road. Another type of road is available, unpaved road, means there is no pave in two sides of the road. Okay. So these two type of road condition can be worked. We have here also we have applied some computer vision techniques to segment, uh, mm, extract this segment of road from these paved road as well as unpaved road, uh, that is mostly is the in the countryside road. So there also we have used some of the you know uh, segmentation algorithm to get the accuracy. Another third type of work that you can do is object detection. So object detection technology is nowadays it is easily available in over the internet, and basically this YOLO algorithm is mostly people are used, uh, and the accuracy level is very high in YOLO algorithm. You can see here it is correctly detected these objects like bus, like car, person. Mm. So all of these object is accurately detected using these algorithms. So we can also work with the uh, detection of hazards object. Okay. Now another area of research is collision avoidance. There also this type of work also is many people are doing this collision avoidance algorithm. How to avoid the collision means if some cars are ahead with you, so how to avoid the collisions? You can slow down, you can go this way, you can go this way, or you can avoid these car like this way. So these are the techniques that obstacle driverless cars are using. So this is another area of research where people are working. And finally, these estimation of risk level that we are discussing. What would be the estimation of risk level that you need to calculate? If in front of you some cars are there and it is moving in a particular speed, and the distance is between your car and the next car is particular distance is there. So what would be the risk level for the self-driving that you need to calculate? Like there are four rules are there. First one key rule number one: if the priority is low and the distance is far, then the risk level is one. Means if there is a huge distance between your car and another car. So similarly, if the priority is high and the distance is far, then it is risk level 5. So if the priority is low, distance is close, if the distance is decreasing, then the risk level is also increasing. You can see from 6 to 10. So this is the four rules. Using these rules, you can calculate the risk level of a self-driving car, and accordingly we can drive. Means the automated car is driving. Okay, so this is also another area of research. Then warning system, a lot of people are working, even students like you in BTech, students, they are also working on these warning system, research work on this warning system. That means whenever this is simple Python based OpenCV work, OpenCV project, you can take this type of projects. Like whenever you close the eyes, and warning system will start, right? So this is basically detecting the basically detecting the human eye, whether it is open or closed. If it is closed, and warning an alarm is generated, that means it is basically a safeguard if you are falling asleep. Hmm. So this type of this is not exactly for the driverless car. Basically it is for the human driven car we are using. Hmm. However, these pedestrian detection means not only pedestrian detection, you have to estimation of pedestrian prediction. That means you have to estimate whether these these pedestrian will move across your car or not, and that you have to predict. So that is another area of research. Okay. So next, sidewalk cyclist detection, that is also important. You need to detect whether some cyclists are there, and it may come come across the road. Uh, so various deep learning algorithms are used to detect these sidewalk or cyclist. So here we have used some of the deep learning reinforcement algorithm. Uh, so I'm not going into the detail of these algorithm here. We have used some DQN algorithm here to for these, you know, um, the the last work that we have done, that is object detection. So there we have used these algorithm. Now this is the experimental results that shows here. Uh, where you can see the predictions. Means if the obstacle is there, this is the agent. So what would be your prediction? Will you go into the left? Will you go into the right, or from the state? So this way mm, you can predict your action. Now this is the robo car that we have used using MicroPython that we have used in our lab, mm, where we have we have used some, though we have not used lane detection. We have it is basically detecting the white lines, and and we have used some obstacle avoidance algorithm. So obstacle we have put into it, and it accurately avoid the obstacle here. Now this is another work we have done, that is lift 3D object. Lift is a data set basically. So we have used lift data set to detect the object, 3D object. Huh. So this is basically done not only for the autonomous vehicle. These object detection can be very useful for the applications like drone, because there you need to detect the 3D object. So here we can see the methodology. We have used UNet algorithm, UNet model here, UNet architecture here, and different algorithms we have used, like YOLO algorithm, we have used VoxNet algorithm. Hmm. And then compare which algorithm shoots better and get more accuracy. So this is the and this is the results. Here is the confidence score calculated for traffic agent detection and classification. Different model that we have used, yellow model, voxelnet model, and UNet model, and for different vehicle as well as pedestrian, or we have used or emergency vehicle. We can see the percentage of accuracy. So definitely YOLO algorithm is much better, you can see, from these two algorithms. And most of the people nowadays are using these YOLO algorithm. So as we are just discussing that UAV, for UAV or flying object, we have used the leaf data set, and from the leaf data set we can detect the different object. Here, the object, obstacle avoidance is different than self-driven vehicle. So that is also that one what we have done with the lift 3D data set. Moving object classification, I'm not going into it or methodology. This is the results of this lift 3D data set, where we can, more or less more than 90% accurately, we can detect the flying object. So coming to the healthcare service sector, after these autonomous vehicle sector, we are going for the next applications area of AI robotics into the healthcare service or hospital assistant. So any questions up to this in the autonomous vehicle area?
Okay, participants, you can ask any questions.
Any questions up to these? We can ask.
Sir, I have a question.
Mhm.
Can you hear me?
Yeah, sure. Please ask.
Sir, could every sort of vehicle can be made into
Hmm.
autonomous vehicle? Is that possible? Like airplane or the train system? If so, then how safe it would be?
No, train would be very safe. And for your information, right now some of the trains, some of the metro rail are using these autonomous driving technology, because it is very simple for metro rail, because there is a single lane, and there is no lane change. Most of the metro railway, there is lane changes are not there. So only you have to run through a single track, and in front of you there will be another metro rail. Okay, so you have to keep the safe distance between these two trains. So that's why some of the places these autonomous trains are metro rails are used. So therefore, we can use in metro rail always, and means trains always, and vehicle to some of the vehicle is testing part of autonomous vehicle, autonomous car. And in case of plane also, definitely there are some autopilot planes, autopilot drone basically it is called. Autopilot drones are there, it is fully automated. And maybe in future we can see autopilot passenger planes. That submarines are there. Okay, so we can say almost all the vehicles can be thank you. Any more question?
Dear participants, if you have any questions, please write down in the chat box or ask yourself.
Okay, so our next area of applications of AI robotics will be on the healthcare or hospital assistance. So in the healthcare or hospital assistance sector, mm, many researchers have worked in this particular field, where AI can be heavily used. Firstly, for the for the patients, like waking up, when to wake up, what would be the temperature. So measuring of the temperature, and that temperature can directly send to the doctor through some app, and as well as to keep the record automatically of the record of the patient automatically. So that is one of the field of research. And and earlier days you can send the data to the doctors, and doctors have to see whether this patient needs some attention or not. But nowadays all these are AI based, that is artificial intelligence based automatic system. So that whenever the data are recorded, the temperature data, the blood pressure data are instantly recording every second. And whenever there is some anomalies are there, it is directly generating some alarm and sent to the doctors. So therefore this type of automated system, AI based system, can be implemented in healthcare service. Other than these mm, during emergency, we can call the ambulance automatically. That means that is also an AI based system can be developed, where whenever there is an emergency, let us suppose you fall down, so your smartphone or your some of the wearable device will detect that fall down, and it will directly call the ambulance without any human intervention. So that is also another type of what hospital database. Maintaining of hospital database is also another type of what hospital management. There also you can work this type of work, means everything will be in you know mm, using the AI part. Uh, so patient measurement data can directly come into the hospital main computer, uh, so that the data processing layer will be easier for them. So that is some of the areas of research in hospital healthcare. Here we have explained some of the research, and it will make you some cheaper solutions. It will be better and faster solutions can be provided to these AI based robotics applications. So other than these also, there are several works people are doing research, though we have not done this type of research, like in surgery, where robots are used for surgery. Though we have not explored in that particular area, but we have done some theoretical research on hospitalizations. Whenever there is an emergency, it will directly call to the ambulance, or the measuring data can be directly fed into a particular app, where it can generate an alarm whenever there is some anomalies are there. That type of work we have done here. Okay. So another type of work can be done in this particular field, that is mm, no, that is we can say some RFID uh, or GPS smart tag can be fed into the in a wearable device, and that can detect the human movement, the patient's movement can be detected, as well as some anomaly can be detected through it. Hmm. Also, we can use some robots for hospital assistance, just like in during the time of COVID, we have seen some of the robots people have used for as hospital assistants. So that type of robot can be used. Though since we have not done much work on these areas, so I am shifting to another area of research that we have done, that is Industry 4.0 and robotics automations. So we have done some research on these Industry 4.0, that is cloud computing, we can say. So all the machines industry earlier industry 3.0 was the revolution was all the machines should be connected to computer. Now in industry 4.0 all the machines should be connected to clouds. So what whenever you are using some machines it should be connected to the cloud so that we can get the data in cloud, we can process the data, and accordingly we can send some feedback into the machines. So that is the concept of industry 4.0. And here you can see how we have used these smart manufacturing technique into industry 4.0. Like we have used these are the technologies can be used like AI, ML, DL can be used where it can applied. It can apply to these big data and IoT and cloud computing, and accordingly these are the area of applications like in design, in process, in customers, in equipment, records, parts, suppliers. Here we can use these. Means let us suppose one of the example I am giving of workforce data. So on the workforce data, you can use deep learning, some machine learning algorithm to make it get better output from the workforce, right? Means we can predict what would be the next month output, if we can use some machine learning algorithm for the last 1 year data. So using this data we can predict what would be the next month output automation. So we can improve the quality, we can improve the energy, we can improve the raw material quality. So this can be improved through these prediction uh, algorithm, prediction analysis. Okay. So these are the results for this. We have taken some data from a particular company, and basically an automobile company. From an automobile company we have taken the data, output data. So from there we have received these results. This is the correlation matrix where we can found mostly the prediction that we have generated mostly satisfy the with the output. Yeah. So these are the robotic automation solutions like RPA, deep learning, ILDL model, and boards. So this is how we can use in industry 4.0, and these are the some of the applications area of industry 4.0. Some or smart automations. These are the outcome. Now this is the model we have used, and this is the results with a different algorithm we have used, and this is the accuracy of different algorithms like SVM, ANN, K-mean square, and KNN, CNN algorithm we have used. Here also precision score can be shown here. This is another area of research, that is IORT, where security and privacy analysis we have done. So this is the surveillance robot, another work we have done on uh, cyber intelligence to improve the crop productivity. So I'm not going to detail on this. This is another area of research. Here also you can do some research work. It is basically on the blockchain. So we have applied this blockchain model on the mobile robot. So this is the crop productivity using machine learning. Some of the plant disease that we have detected using these camera. We have used Raspberry Pi here as a to develop the device, and the data set we have collected is fed into the Raspberry Pi, and an LCD display were there. So basically we have used some of the plant disease. We have detected some of the plant disease to to improve the crop productivity, to alarm the farmer and to improve the crop productivity. So our next applications is humanoid or personal robot. We have seen uh, in recent years, in last few years, some humanoid human robots are used in specifically for as a rescue robot to rescue people from any natural disaster area, or even some of the people they are taking these humanoid robot as a personal robot to play with them, to chat with them. Hmm. So this is the current development. So before discussing on this, any um, uh, Nasifa, can you
Yes, sir.
is it interesting to you, means audience, or not?
Yeah,
Can you
it
say some
is.
can you say some feedback about this so that I can continue with to do some research work, you have to work on some particular subtopic, that may be emotion detection. So, emotion detection is a good field of research work. You can work on energy efficiency, you can work on integration or control structure, okay, or perception, that means face or object detection. So these are the some of the areas of research you can do. So we have done some of the work on emotion detection or emotion prediction, you can say. Hmm. So emotions are very important because as we have said, ki nowadays all the humanoid robots that we are trying to develop are like chatbot. So chatbot, as a chatbot, it should detect your emotions when you are talking to someone. You need to detect what that people is thinking, or what is he is trying to say. So that means the emotions detection is very important for us, and we are it is still not possible to get 100% accuracy on emotion detection. So that's why many people, many group of researchers are working on emotions detection, and we have also worked on emotion detection. So classifications of emotions are classified into two types: continuous emotion and discrete emotions. Okay, and this is the
Sir, this emotion is predefined in this robot.
yeah, predefined. No, it is basically we have to detect what type of emotions it means. It is basically detecting your emotions, and accordingly it will work. Let us suppose there is a humanoid robot, and if it detects you are crying, so it should detect you are crying. Then it will ask you, means it should be perfectly detect your emotions that you are crying, and the action will be there. It will ask you the question, why are you trying, or it will call some emergency service, ambulance or hospital. That is our main objective. Okay, so basically four field, most priority emotions are there. What are they? Angry, joy, then uh, tired and sad. Okay, so these four emotions can be detected. This is the arousal level. For these angry and joyful, the arousal level is high. Hmm. And this is the valence level. Okay, so this way we can detect the, we can frame the algorithm for emotion detection. So so other than these four way of main emotions, there are seven basics emotions are there. Ah, so what are they? Joy, sadness, anger, surprise, acceptance, disgust, expectancy, and fear. Uh, so some of the robots, they have these a detection algorithm of these all seven algorithms. One of these, I'm not going to explain these complexity of emotional classification. I'm coming into these. Uh, okay, these I have skipped. Anyway, so so in our robot, we have we have detect only four. We have tried to detect only four emotions out of these, that is joy, sadness, anger, and surprise. These first four emotions that I'll show you in next after 2 3 slides. Okay, so here I'll show you how these robots, humanoid robots work, uh, or we can say machine human machine interface. This is called human machine interface, or HMI. So basically the program is written on this abstraction area, abstract state it is called. Okay, and user can directly write some program in the abstract state. Okay, write some command here. Now there is a component called learning component. There is some area of learning component in the humanoid robot. Now as per the abstract, whatever the user has written, it is it has some interface, and as per the interface, it is activate, and the activate from the behavioral elements, it is action means working. That means it is directly these behavioral elements is basically rotating the motors. It is for a chatbot, it is switching on the speaker. The speaker is activated through this action. Now there is also perception. That means microphone is there. So from the microphone, the input, it is some speaker. From the speaker, sorry, output, we are getting the output, as well as from the microphone, the perception input are getting into the behavioral level, and from the behavioral level to interface level, and from the interface level to these learning component level. So at the learning component level, huh, what happened, the are taken in the environment, and the input is also getting from the environment, and it is saving at the learning components level, this layer. And as per the learning process, this abstraction level changing, the abstract whatever defined by the user, it is changing due to these learning components. So this is the whole working principle for these humanoid robot. Okay, means the training AI part. So this is the robot Maria that we have developed. We have named it Maria, multiple application robotic intelligent assistant. So basically, these robot can be used as a chatbot, as a receptionist chatbot. It can be used as demonstrator. Means follow me robot. It can show you, the area of in a company. It can serve as a key, guest, as a service robot, uh, as well as it has the facility to work as security robot to detect person, to detect the intruder. So these are the features of that this robot. It is a 4 feet height, carbon fiber made robot, and this is the emotion recognition, emotion recognition experiment that we have done, the algorithm that we have used, and you can see the four. This is a RGB LED, and as per the detection of emotion, these LED color is changing. You can see it is for surprise. It is blinking, um, pink. For these sad, it is blinking in blue. For angry, it is blinking on red. So as per the emotions, the output is changing. So it is showing, it is the experiment that we have done, is showing how the emotions are detecting accurately. You can see almost all these emotions are detected more than 90% accuracy. So this is the future of humanoid. This is the future of humanoid, where we know, as we are mimicking the human. We are inspiring from the human, so we are trying to develop the humanoid as human. And as we can see, the human behavior has changed from, like, we right now we have little movement and exercise. We are basically exercising on brain only. And some of the scientists are predicting that our human brain would be head will be larger than body after few hundreds of years, after few generations. Okay, so researchers also doing in that particular field, because right now we do not need to movement. We only work on the brain, right? So therefore we have also there is also paradigm shift from mechanical robot to AI ML robot. And if you see nowadays the modern robots, one of the example is Sophia could not walk. Okay, she could not walk. But earlier robot, you have seen Honda Osimo. It can run, it can play football. But the modern robots, they cannot even walk, because the application level has changed. Hmm. The area of applications, the conception has changed from mechanical to AI, intelligence based, or intelligence. Whenever we are putting some intelligence, so the application areas has changed. So one of the examples is Sophia. uh, so here we also are thinking on the same directions, like technologies are always there whenever there is a crisis in human society. Now what are the major crises in human life in future? We have, we can say, nuclear family. Now families are nuclear family only. Only couples are staying together. So the families are nuclear family, and also we have to work with staying single due to job and uh, other difficulties. So therefore we sometimes we have to stay alone. So we need a companion, right? So what would be the technological solutions for this companion? A humanoid robot. So therefore, the future scope of humanoid robot, or we have also thinking for Maria is it should be work like a companion. It should be with you. It should be with human together, and it will work as a human, as a companion, as a friend, as like a parent, or like a family member. Like this key, it will stay with human. It will observe every movement of human, and it will chat and advise. Like you are, it is staying with a man, and he is working. He is working up to 2 p.m. or 3 p.m. Now these humanoid will observe it is this man is skipping the lunch, so it will come to that people and ask, hello Mr. X, why are you skipping your lunch? Please take your lunch. So just like your friend, just like your family member, it will work. So that is the future scope of humanoid robot, and we are also working on that particular direction. However, there are several challenges on working on these direction, like limited ability till date. We have not that much of ability to or we can say feasibility to develop that kind of humanoid robot, and the and and also slow real-time response, because this type of robot will stay with you, and in case of some emergency, how to react. It cannot handle that emergency situation, as well as it has very slow real-time response. So it needs I have some time to get better hardware support to compete with better real-time response. Hmm. And another most challenging issue is the privacy issue, or we can say security issue, because it is observing every movement of human, right? So therefore, it should be stored in the server of this robot. So whatever privacy you have, it will be stored in the humanoid robot. So therefore, privacy issue is there, as well as security issue. It will observe every movement of you. So it will detect at what time the people are leaving from the home, go for the work, ah, and when they are returning back. So there will be a security issue, na. So that type of challenges are there for this type of humanoid robot. As well as last but not the least is the high cost, because this is a customized robot for it should be designed for a particular human or particular application. So therefore, it needs definitely high cost. So these are the few of the challenges for these humanoid robot. Okay. So these are the some references that I have used for this particular talk, and basically we have taken some of the book chapters, some of our book chapters from these three books. So this is my contact details. Also, anyone want to have connect with me can send me a mail, and I'll be happy to answer any questions if you have. So
Oh, okay, sir. Thank you so much, sir, for your informative session.
thank you. Any questions or queries?
Oh, okay, sir. It's time for the question answer session. I would like to request the participants, if you have any questions, you can write it down in the chat box or unmute your microphone and ask yourself. Dear participants, please respond if you have any questions.
I have got two questions in the chat box. First one is, recently some people in Bangladesh are committing suicide in Facebook Live. how intelligently this can be ended by using robotics? Very good questions. Mohammad Firoz Ali has raised these questions. Very good questions. Definitely, it can be stopped. This type of work, this type of suicide work can be stopped using AI robotics. I think these Facebook people, they have already started research with this, because it can detect the suicidal attempt. Whether it is these people is going to be going for the suicide, these things can be definitely detected through computer vision technology. Since you have seen, we have done some work like a prediction of human mind. We have done some research work predicting the human mind, whether these human is will be crossing the road or not. So that it is a prediction. So similar prediction can be done using these AI algorithm, whether this human is going for the suicide or not. Definitely some of the suicide like hanging. So this type of suicidal attempt can be stopped using these uh, you know research, AI ML research. Okay. So another question. I have a query. What is the future of nano robotics? Yeah, nano robotics. Though we have not worked on this particular nano robotics, uh, because there are some hardware limitations on these nano robotics. Um, mm, Definitely, there are some features like nano robots can be sent through human body under the skin for some drug injections, some particular surgery can be nano robots can be used. Mm. But I do not have much information on these nano robotics. Any more questions?
Yes, sir. I have a question.
Sir, there's a
Ah,
question in the chat box.
okay. What tools should I use to learn to implement or simulate robotics? So, mm, Sh- Shair Alam, can you elaborate these which particular robot you are trying to work?
Sir, the robotic algorithms. I want to know what tools should I learn to implement these algorithms for
Okay,
robotics.
okay. So, for these, basically, whatever machine learning algorithm we have used, most of them we have used means with Python. Okay, so you can search on the net artificial intelligence or machine learning algorithm using Python. Okay,
Thank you,
so
sir.
you need to learn Python for these AI or ML algorithm. Any
Sir, I
more
have a
questions?
question, if you mind.
Mm-hmm.
What are the security concern about artificial intelligence? Because it's connected to the internet and the network. So hackers can easily bug into the system and, you know.
Yeah, I got your point, but that depends on whether you are allowing your device to the cloud or not. Means this cloud is also it is different than internet. Okay, you can use your personal cloud. It is different from the internet. Internet is like everything is storing in the internet, but this cloud concept is not like that. You can use your personal cloud. So no one can access your personal cloud other than you. If you have a good cloud security, so no one can access your cloud. Also, you can use your own network uh, for some AI or ML work in a particular area. That is also possible. without internet also it can be you can run your system, that is AIML system can be run without internet also. So therefore, two way to safeguard from the hackers, either you should not connect to the internet, you can use your own network, and secondly, if you connect to the internet, you can use your own cloud system, that is also possible. So this way you can safeguard your device.
Yes, I
Okay.
got it. Thank you.
So any more
Sir,
questions?
I have a question.
Uh-huh.
Sir, could badly infected human organs replaced by AI robots? I mean, temporarily or permanently?
Organs, there are possibility uh, like 3D printed human organs developed, like artificial kidney can be developed, but we have not received much success on these areas till date. There is not much success, but definitely in future maybe some 3D printed organs may be replaced. One questions I have received from Ifat Aras Sharmin. So what step should I take to study, learn and implement robotics, especially humanoid, efficiently as a beginner? So for humanoid robot, as I have said, humanoid is a huge subject. Okay, you have to start from a basics. So basics of humanoid can be learned. Then you can means what are the subtopics associated with these humanoid robot that you need to learn, or you can go for a specific topic like emotion detection. uh, so for emotion detection, you need to learn first Python, then go for some AIML and learn some AIML algorithm. First, learn some basic algorithm of artificial intelligence, then machine learning, then deep learning. Then you should apply. Mm, you can take some data set and you can apply. You can do some work on algorithm. Try to develop a model, write algorithm, and do some training on the algorithm and get the result and match with the test data. So this type of work you can do, but definitely you should focus on a particular problem, not as a humanoid, because as humanoid is a huge subject. Any more question? Some of
So
the
there's a question. Yes, sir.
hmm, could you please refer some of the books? Basically, all these are research topic, and though I have already referred to books. Uh, uh, I hope you have seen in my last slides. Two books were there, one from Springer, one from Elsevier, hmm, uh, on AI, humanoid AI robotics. But these books are research topic, based on research topic. Okay, so I should suggest you can download some papers on particular work you want to start with, uh, and go through those research papers, study those papers, and make a review note on it, uh, and then you can start your own research.